about the turbocharger, why we need turbo or supercharging, the difference between supercharger and turbocharger, and also inshallah in this chapter we'll consider some basic thermodynamic for the connection between the turbine and the compressor in case of turbocharger, and the matching between the engine and the compressor and turbine in case of turbocharger, because turbochargers they have separate shaft, compressor and turbine. Compressor takes the exhaust gases, then it can convert it to shaft power to drive the compressor. It is running at a given RPM. This RPM is much higher than the RPM that the engine is running on, and it provides a certain amount of mass flow rate of air to the engine. So the engine should match actually with this amount of mass flow rate of air to calculate the amount of mass flow rate of fuel, and then the engine will be running at a given RPM to given a certain power. So in this case, if we have a turbocharger and the engine connected with the engine, we have to match actually the operation between, to have a smooth operation between the turbocharger and the engine in this case. Inshallah, we'll be looking about this matching, how to calculate it, how to match them theoretically, and they calculate actually based on the mass flow rate of air out of the turbocharger, how we can calculate the mass flow rate of fuel, the fuel to air ratio, and also how we can calculate the engine power in this case. Also, we'll be talking, inshallah, about the advanced turbocharger development, recent version of turbocharger that has been already connected to some recent cars, recent version of car, and also we'll be talking about actually the application in which you can have turbocharger or supercharger. The idea, shabab, of turbocharger, why do we need turbocharger or supercharger? So the idea actually is to provide the engine with more amount of air. So that for a gasoline engine, like a gasoline engine, usually the fuel to air ratio is fixed. It's usually the gasoline engine, shabab, as we said, is working under a stoichiometric condition. So usually the fuel to air ratio is the stoichiometric fuel to air ratio, which is fixed at almost, and this is one of the drawbacks of the gasoline engine, that it has fixed fuel to air ratio at all engine load, from part load until actually we have the full load. So usually the gasoline engine adjusts the operation based on the intake amount of air. It calculates the amount of fuel based on the stoichiometric combustion based on this fixed fuel to air ratio in this case. But if we are able to increase the amount of air, that means in this case the engine, the ECU will adjust the amount of fuel to have actually a fixed fuel to air ratio. That means the amount of fuel will be increased in this case. But if we increase the amount of fuel, so that means in this case we are increasing the power output of the engine. So in this case we can increase the power output by increasing the amount of air input to the engine. But how we can increase this amount of air? Actually, we have three methods in order to increase the amount of air into the engine. The first method is to increase the piston displacement, just to design the engine to have actually bigger displacement volume in this case. But in this case, if you have an engine size with bigger displacement volume, so the engine size will be increased in this case, and also the engine weight will be increased, okay? And will result actually in destruction and some additional cooling problem due to the engine size in this case. And actually increasing the engine size even will increase the fuel consumption, because the engine itself has heavy weight and the car is already actually carrying this engine. So it will result actually in some adverse effect. So this option is not preferred. So the other option actually is running the engine at higher speed or higher RPM. Running the engine at higher RPM, this is actually is not the choice under all operating conditions. So in some cases you are actually just driving inside a city, so you are limited to a given speed. So also if you are driving under highway and you are going actually to very high RPM in this case to draw more air to the engine, in this case actually the friction losses inside the engine will be much increased in this case, and the power output also will be adversely affected in this case. So the third way to increase the mass flow rate of air to the engine is to increase actually the charge density, to increase the density of the air. If we are able to increase the density of the air, that means we are increasing in this case the mass flow rate of air. Increasing mass flow rate of air will increase the mass flow rate of fuel, and the engine power in this case will be increased. If you look at it, inshallah, we'll be talking about all of these parameters, inshallah, in the next chapter, which is the engine performance. We have the engine power, we call it the brake power. Brake power, inshallah, is the power of the engine on the crankshaft. Inside the piston here, if you look, inside the piston, above the piston here, actually we burn the fuel, we generate heat. This heat will be converted to work. It will be pressing this piston. This is actually the net work that we have calculated through the cycles, the engine cycle. We have learned how to calculate this net work. But this network, if you remember, we call it actually the indicated work. Indicated work, which is the work generated inside the cylinder here. Okay? But if you look here, this cylinder is connected to the piston, and this piston actually is connected to the crankshaft. So here, actually, due to the friction losses between the piston and the cylinder, and through actually this connecting rod, the connection between the piston and the crankshaft, and the friction losses in the crankshaft, so in this case, the network actually, or the indicated power inside the cylinder, will be reduced here actually to what we call the brake power. So the brake power is the crankshaft power, which is equal to the torque multiplied by the omega of this crankshaft. This crankshaft is rotating at a given RPM, and in this case, the power on this crankshaft, which is the final power ratio. Brake power is the final power in the crankshaft, is equal to torque multiplied by omega. But the network that we have calculated based on the engine cycle analysis, we call it the indicated power. And the difference between the indicated power and the brake power, indicated power is equal to the brake power plus the friction loss power. The loss power due to friction, due to the movement of the piston, and due to the transfer of the power actually from the piston, from the linear motion, or actually the intermittent motion. In this case, we can convert it actually to angular motion through the crankshaft. So the indicated power, the power generated inside the piston, is equal to the brake power, the power in the crankshaft, plus the friction loss power in this case. So the final power out of this engine, we call it the brake power, which is the crankshaft power. This brake power is equal to the torque on this shaft multiplied by the omega, which is the angular velocity. So this torque multiplied by omega, which is 2 by n. If this n is the revolution per second of this crankshaft, so in this case we can define the brake power is equal to the torque by omega, or we can say the torque will equal to the brake power divided by omega, which is 2 by n in this case. Type 2 by n is the number, actually n is the number of revolution per second. If this engine actually for only one cycle of the engine, one cycle, in case of one cycle, so in case of 4-stroke engine, and we have one cycle, for a 4-stroke engine and we have one cycle, that means the crankshaft will be running actually in this case 2 revolutions in order to have a complete cycle in case of 4-stroke engine. So for one engine cycle, this n will equal to 2 in case of 4-stroke engine, and in case of 2-stroke engine, for one cycle actually we have a number of revolutions. The number of revolutions in this case will equal to 1 in case of 2-stroke engine. Anyway, inshallah, we'll be talking about this later on. But from here, the torque will equal to brake power divided by the angular velocity, which is 2 by n in this case. Type, we have the brake power based on the thermal efficiency that we have defined on the engine cycle. The thermal efficiency is equal to the brake power divided by the fuel input, which is mass flow rate of fuel multiplied by the heating value. The thermal efficiency is equal to the net work for the final power output, the net power output of the engine divided by M dot fuel multiplied by the heating value. Or we can say the brake power will equal to eta thermal multiplied by M dot fuel multiplied by the heating value in this case. So let's define this. So we can just define the torque as function of mass flow rate of fuel, and then based on the fuel to air ratio, we can define it as function of the mass flow rate of air. So that if we increase the mass flow rate of air, that means actually we are increasing, in this case, the power of the engine. So in this case, we have defined the power. The torque is equal to the brake power divided by 2 by n in this case. And the brake power is defined as thermal efficiency multiplied by mass flow rate of fuel multiplied by the heating value. This is divided by 2 by n in this case. Okay, but we have the fuel to air ratio is fixed. Is almost actually 1/14.6 in case of gasoline engine C8H18. The fuel to air ratio based on stoichiometric operation, lambda is equal to 1, will equal to this value, which is equal to the mass flow rate of air divided actually by the mass flow rate of fuel. Or we can say the mass flow rate of fuel will equal to mass flow rate of fuel So fuel to air ratio is mass of fuel divided by mass of air. So that we can say the mass of fuel will equal to the mass of air multiplied by the fuel multiplied by the fuel to air ratio. Let's take this and then we can substitute here. Then we can get the torque will equal to eta thermal multiplied by mass flow rate of air multiplied by fuel to air ratio multiplied by the heating value divided by 2 by n in this case. So here, شباب, we can define the torque out of the engine on the crankshaft as function of mass flow rate of air multiplied by the fuel to air ratio, which is fixed in this case. So if we are able to increase the mass flow rate of air, that means in this case we are able to increase the torque out of the engine for fixed value of fuel to air ratio under stoichiometric operation for a gasoline engine. Usually, شباب, the mass flow rate of air, if we have engine like this is the engine in this case, and this is the intake valve, and here we have the exhaust valve. So let's say here, the piston here is at the top dead center at the end of the exhaust stroke. So we have to start the intake stroke here. So while the intake stroke, we should have air is coming in. So the piston will be moving from the top dead center to the bottom dead center. And the air, the incoming air in this case, will be just filling this volume. The volume in this case, شباب, is equal to what? Is equal to the displacement volume. So that means the mass of air coming theoretically into the engine should equal to the density of the incoming air multiplied by the displacement volume of the engine, because the piston will be moving down and the amount of air coming in will be just filling this displacement volume. So the mass of air will equal to the density multiplied by the displacement volume in this case. Okay, and rho n. Yani here, if you look at this expression, you will find here we have another efficiency, which we call it the volumetric efficiency. This is the amount of air coming into the engine, we call it the mass flow rate of air theoretical to the engine. But usually the mass flow rate actual to the engine is less than the theoretical value. It is equal to the volumetric efficiency multiplied by the mass flow rate theoretical. Or the volumetric efficiency is equal to the mass flow rate of air actual divided by mass flow rate of air theoretical. As you know, if we have any flow and we have any kind of restriction for this flow, like if we have a venturi or something, or if we have an orifice, so in this case, this intake valve, the intake valve, the area around the intake valve here is limited, based on actually in reference to the intake manifold, the area of the intake manifold. So it acts like a kind of orifice or a kind of venturi. It's a kind of flow restriction in this case. So we have to add in this case a coefficient of discharge. Not all of the incoming flow actually will be coming into the engine. So due to the existence of the intake valve, and also due to the flow actually in the intake manifold, also شباب, we have a throttle valve which is connected to the accelerator pedal. And this throttle valve also, it restricts the inlet area in this case. So all of these are a kind of flow restriction in this case, which will result actually that the mass flow rate of air actual to the engine will be less than the theoretical value. Theoretical value is equal to the density multiplied by the displacement volume. And that's why we have to introduce here a volumetric efficiency to the engine to take care about the effect of the intake valve and also about the throttling effect of the throttle valve in this case. But anyway, the mass flow rate of air actual in this case will equal to eta volumetric multiplied by mass of air theoretical. And mass of air theoretical is density multiplied by the displacement volume. This density is pressure, the intake pressure in the intake manifold divided by R multiplied by the intake manifold temperature of the air multiplied by the displacement volume. And finally, what I want to say here, if we are able to increase the pressure of the intake air, so that means we are able to increase the density of the air. Density of the air is increased, so the mass flow rate of air will be increased. Mass flow rate of air is increased here, that means actually the torque or the power output of the engine can be increased in this case. And this is the idea. This is the idea, شباب, why we use actually the engine turbo or the supercharger in order to improve the power output of the engine for the same engine size. We can increase in this case the power output. Type to increase the pressure, شباب, of this the air pressure or the incoming air pressure. So in this case we use an air compressor. This compressor takes the air under atmospheric condition and it raises its pressure so that we can increase the density of the air and then we can increase the power out. So the purpose here يا شباب of supercharger or supercharger or turbocharger, we'll be talking about the difference between both of them. The idea here is to use a compressor. Then this compressor can compress the air, raise its pressure, so it can increase the density of the air. So the mass of flow rate of air to the engine will be increased, and also the mass flow rate of fuel will be increased accordingly, and then we can generate more power output in this case. In case of supercharger يا شباب, this compressor is driven through a part of the crankshaft power. So we have a connection between the crankshaft and the compressor. Then the crankshaft, so using part of the power output of the engine, we can drive this compressor. You can look here يا شباب. So usually this is actually the crankshaft of the engine. We use a small size gear in order to increase the running RPM of the compressor in this case. So usually we have big ratio of the gear ratio. Then this compressor can be running at higher speed in this case. Usually, and this is the compressor, and the compressor in this case, most of the cases will be a centrifugal compressor. Usually, شباب, in the engine car, if you are driving your car, you will find the engine RPM most probably is around a kind of 3,000 revolution per minute, from 2,000 revolution per minute up to 3,000. So in this case, with this reduction gear, so that we can increase the compressor shaft, the speed of the compressor shaft in this case, it can approach a value of 10,000 RPM. Okay, but this is a maximum value for the running RPM for the shaft of the compressor. In case when we have a supercharger, the compressor is driven through the shaft power out of the engine itself. In case of turbocharger, as you know, in this case we use an exhaust turbine. This turbine actually is connected. It takes the exhaust gases. You can look here. So this is the turbine and compressor. They are connected on the same shaft. The exhaust gases out of the engine are just coming into this turbine. It will drive the turbine. Here you can look at this point. So we reduce the area so that actually it can act as a nozzle. So it can generate high velocity jet in this case of the exhaust gases. This high velocity jet will hit the turbine blade. So it will rotate the shaft of this turbine. The turbine is connected in this case from the other side to a compressor that it can take actually the atmospheric air, then it can raise its pressure, and then it can deliver it to the engine in this case. So in this case, the turbine, one of the main advantages of the turbocharger is that it does not depend on the engine power. It does not take part of the crankshaft power in this case. Just we make use actually of the blow down energy, the energy actually of the exhaust gases. We just take it, then it can drive the turbine, and the turbine in this case can drive a dynamic compressor in this case. So we have a dynamic turbine. Dynamic means we have blades, and it is driving actually a dynamic compressor. And in this case, as it is separate from the engine shaft power, in this case the RPM actually of the shaft of the turbocharger can approach values of about 100,000 RPM in this case. So in this case, the running RPM of the shaft in case of turbocharger is very high compared to the case of supercharger. But in both cases, if we raise the pressure of the air, that means in this case, when we raise the pressure, the temperature also will be raised. So raising the pressure will raise the density in this case. But when the pressure increases, the temperature also will be increased. And this will result actually in reducing the density again. So in both cases of turbocharger or supercharger, we have to use intercooler. This intercooler just cool down the compressed air after the compressor before we introduce it actually to the engine in this case, so that we can improve the density of the air in this case. So the higher, this actually after cooler, we said it is a must. We have to have in case of turbocharged engine, we have to have after cooler, or what we call actually in this case intercooler. The value of this intercooler, it will raise the density, it will reduce the temperature of the air so that it can raise the density, and then we can improve the mass flow rate of air, and we can improve the brake power in this case. One other use, if we are using a turbocharger or supercharger, in this case it will raise the temperature. When we compress it, it will raise the temperature. If we have higher charge temperature, when it is introduced to the internal combustion engine, it may result in self-ignition of the fuel in case of a spark ignition engine, and this may result actually in engine blocking. So we have to reduce this temperature to have يعني low tendency of the engine, to have the engine locking, and also to improve the efficiency in this case. However, يعني this part يا شباب after cooler is just an additional part, so it will increase the complexity and also it will raise the capital cost actually of the engine in this case. Okay, is that clear يا شباب?
Yes.
طيب, here is the supercharger. The objective, as we said, in case of supercharger or turbocharger, is just to overcome the effect. يعني in some cases to overcome the effect of high altitude, like if we have a stationary gasoline engine just is sitting at the top of mountain or something to generate electrical power or any kind of application, or also شباب in case of aircraft. So the idea of the jet engine, also we have a compressor and we have a turbine. And in this case, we have to use a compressor in order to raise the pressure of the air and introduce more air to the turbine in this case, to have more engine power. So the idea of turbo or supercharger is to just, one of the uses actually is to overcome the effect of high altitude, because at high altitude, يا شباب, what will happen? What will happen to the density of the air?
It will be lower.
Yeah, it will be lower in this case. So it is better in this case if you have a gasoline engine or any engine at high altitude, at the top of mountain or something, or an aircraft application. So it is preferred in this case to use a turbocharger so that we can increase the density of the air using this turbocharger. Also, شباب, using turbocharger will increase the mass flow rate of air to the engine, will increase also the mass flow rate of fuel. That means it will increase the engine power for the same engine size. That means actually in this case we are increasing the engine power per unit volume of the engine or per unit weight of the engine. Also, it will reduce the size of the engine to fit with a given space. In some application like locomotives or marine engine, so in this case the size to put an engine is limited. The space is limited itself. So in this case we prefer to use turbo or supercharger so that we can increase more power from a small size engine, so that it can fit with the space. Also, it can increase, as we said, the power output by increasing the mass flow rate of air. It can increase the mass flow rate of fuel, and also it can increase the power output in this case. So we have different positive effects, شباب, for the turbocharger or supercharger. Power output will be increased. The mechanical efficiency also will be improved in this case. Mechanical efficiency, شباب, is the ratio between the brake power, the crankshaft power, divided by the indicated power, which is the power inside the cylinder itself. So when we have higher power inside the cylinder, that means we will have higher brake power in this case, and the mechanical efficiency of the engine will be improved. Also, شباب, one main advantage of supercharger or turbocharger, if you have a car turbo or supercharged, it will reduce the specific fuel consumption. The amount of fuel reduced, the amount of fuel consumed per 1 kilowatt power output will be reduced in this case. That means also the fueling rate for your car will be reduced. Also, using a turbo or supercharger, it will provide higher intake pressure. So when the piston is at the top dead center, we have some residual gases from the previous cycle. If the incoming air is coming at higher pressure, so it will be able actually to scavenge those exhaust gases out of the engine in this case. So it has a lot of advantage: increase the power, reduce the fuel consumption, and we have better scavenging process in this case. طيب, the type of supercharger يا شباب. So here we are يعني talking about supercharger. The type of supercharger, we have the positive displacement type, in which we have a volume of air strapped actually to the compressor, and through the movement of the boundary we can reduce this volume so that we can increase its pressure. So we call it positive displacement in this case. It can be rod type, vane type, or it can be screw type. We have another kind of compressor design for the supercharger. We call it dynamic compressor. Dynamic compressor can be either axial or radial, or what we call it actually centrifugal in this case. The idea in this case, شباب, to increase the pressure is to generate a tangential velocity. This tangential velocity can be converted actually into pressure through a diffuser shaped flow passage in this case. So if we pass the flow, forces the flow to go through a diffuser, and we can generate a tangential velocity, this tangential velocity will result actually in increase in pressure. And the design in this case, we call it the dynamic compressor. I will show you this right now, inshallah, how we can generate this high pressure in a dynamic compressor. For the positive displacement compressor, as we said, usually we have different kinds. Either we have the rod type, vane type, or a screw type, all of these are actually kind of positive displacement. Also, we may have piston cylinder compressor, in which we can have actually draw the air while the piston is moving down. Then this intake valve will be closed. Then we can compress through the movement of one of the boundary. We can compress this air to smaller volumes, and we can increase its pressure. Also, the whole idea, Shabab, the idea of all positive displacement is to draw the air of bigger volume. Then through the movement of boundary, we can reduce this volume. Then we can increase the pressure of the air. Like this, also we have the route in which we have two vanes that are actually rotating counterflow to each other. Air is coming here at the inlet where the volume of the air is big. This volume will be just here, Shabab, trapped between the blades to a smaller volume, and then it will be compressed and leaving from the other side. We have also the kind of sliding vane, but a sliding vane which is sliding actually on the outer casing, the inner part of the outer casing. But this will get hot after some time of operation, and it will generate actually more friction losses. But anyway, the air is coming here in the bigger volume between the two blades here. Then this is a sliding vane, and it is eccentric. So while it's movement, so the volume between the two blades will be reduced, and in this case, the air will be leaving from the other side with a smaller volume, and it will be actually of higher pressure in this case. The root vane, Shabab, also can be spiral. It can be helical design. The helical design is to have the helix. We have helix in the flow direction. The flow coming here at the bigger area between the roots, and it is a helical shape. So we reduce much the volume in this case, or the area between the two blades in this case are much reduced. So it can result in this case in much increase in the pressure in this case. Usually, Shabab, the efficiency of the root design compressor is almost about 50%, but this efficiency can be increased actually up to 90% in case of a screw design. This is, Shabab, the screw design compressor, in which we have two rotating shafts, and it is actually of a spiral shape. If you look here, the air is coming at the top at the bigger volume area, and this is actually a spiral shape. Through its movement, it compresses the air in very small volume, and then the air will be leaving actually from the bottom at higher pressure in this case. So air is coming here, it comes from the bigger volume, and through the movement of those two counter-rotating shafts, the volume of this air will be much reduced between the moving blade, and then its pressure will be increased, and it will be leaving here down there out of this screw design. You can look here, Shabab. This is the screw design compressor.
These chambers are connected to the suction nozzle via ports. As the chambers enlarge, they are filled with gas flowing in through the nozzle.
So here is the
To understand the compression process better, let's look at an individual chamber. It enlarges, is filled with gas, and then closed by a circumferential edge in the casing.
So you can see here, Shabab, the volume of air while the movement of this screw, the volume of air is just reduced. You can see the volume.
The rotors now transport the gas to the discharge side, where the chamber shrinks and the retained gas is compressed.
So while
if you are playing the video, we cannot hear your voice. So either we can hear you talking or the video. Your voice gets cut off when you play the video, yes.
Sure. So let's make it again, Shabab. So here is a video. So please hear to it.
Nozzle. To understand the compression process better, let's look at an individual chamber. It enlarges, is filled with gas, and then closed by a circumferential edge in the casing. The rotors now transport the gas to the discharge side, where the chamber shrinks and the retained gas is compressed. Let's view the process again.
So this is the idea, Shabab, of the screws, that we can have the air at bigger volume, and then we through the movement actually of this screw, it can reduce the volume of the air, then we can have it at higher pressure at the outlet. We have another, this design, Shabab, it can, have good movement, it can trap a good amount of air in this case, and it can raise the pressure effectively with efficiency up to 90%. But this kind, Shabab, of a screw design, it cannot reach actually this efficiency unless at higher RPM. So usually at lower RPM of your car, in this case actually the screw will not result actually in any addition to the engine. And this is one of the drawbacks of the turbocharged car. Under lower RPM, usually the boost coming from the turbocharger or supercharger is not case. In this case is very low due to the lower RPM and lower engine power. So in this case, the mass flow rate actually of the air will be reduced. And in this case, the turbocharger or the supercharger does not add actually any bonus to the engine in this case, unless we have higher RPM. At higher RPM, the effect of turbo or supercharger will be the most in this case. And also the compressor, as you can see, the compressor at lower RPM will not result actually in effective compression of the air in this case. Okay, so this is one of the drawback of the screw, or this is a drawback actually in generally for super and turbocharger in this case. Right, this is one design شباب for, we call it the positive displacement design of the compressor in case of supercharger. We have another design which we call it the dynamic supercharger. The dynamic supercharger شباب, in which we have blades. Those blades actually generate a tangential velocity. This tangential velocity can generate pressure if we pass this flow through a diffuser shaped flow passage in this case. So the idea here is to design the compressor, centrifugal compressor, or even the axial flow compressor, is to design a diffuser shaped flow design. Then we can generate, in this case, we can generate flow pressure. If you look at the centrifugal compressor, so this is a kind of centrifugal compressor. Usually we have the impeller, and actually this impeller, inside this impeller we have the blades. Usually the flow is coming actually in the axial direction to this centrifugal flow compressor, and it will be leaving between the area between the blades. If you look at the area between the blades, شباب, for any two adjacent blades, you will find the area is increasing in the flow direction. Also here, شباب, the clearance between the impeller and the outer casing, the flow will be just collected here, and it will be just flowing through actually this clearance between the impeller and the outer casing. If you look at this clearance even, the area in the flow direction is also increasing in this case. And all of the design of this compressor should be actually all the flow passages should be taking the diffuser shape. So what does it mean about diffuser shape? Diffuser shape, that means the area is increasing in the flow direction. So if we have a given mass flow rate of air, mass flow rate is density multiplied by area multiplied by the velocity. Usually it is a steady flow compressor, so the mass flow rate is constant. So in this case, if the area is increased, that means the velocity will be what? The velocity will be reduced in the flow direction. Reducing the velocity based on the Euler equation, delta V is equal to minus rho V multiplied by delta V. We have a negative sign here. That means the pressure is inversely proportional to the velocity, or pressure is proportional to 1 over the velocity. So usually if we have the velocity is reduced, that means in this case the pressure will be increased within the system. So the relationship between pressure and the velocity is the reverse. When the pressure is increased, the velocity will be reduced. If the pressure is reduced, that means the velocity will be increased in this case. Like if we have a diffuser shaped design, that means in this case, if the area is increased in the flow direction, the velocity of the flow will be reduced, and the pressure in this case will build up within the system. And this is the idea of the compressor in this case. We can generate a tangential velocity component through the movement actually of this impeller, this shaft. It will force the air to go between the blade. The design of the blade itself, it takes the area of diffuser, so the area in the flow direction should be increasing, and also the clearance here between the impeller and the outer casing, the area in the flow direction also is increasing. It takes the shape of the diffuser. Then in this case, the velocity will be reduced and the pressure will build up within the system. Even if you look at the outer casing of the compressor, in case of centrifugal compressor, also the area is increasing in the flow direction to reduce the velocity of the flow. Then we can build up actually the pressure within the system in this case. This is what we call the centrifugal flow compressor. We have another design of flow compressor. This flow compressor is characterized by lower mass flow rate of air, or in case of a small engine. But usually in the cars, the mass flow rate of air is small. So in most of the cases for turbo supercharged car, we have this design, which is a centrifugal flow design in this case. But in case if we have a turbine for a jet engine or something, then in this case we need more flow rate of air in this case. So in this case we have to use what's called the axial flow compressor. The axial flow compressor, also we have an impeller which is rotating. It takes the part of the turbine. This impeller we have, in this impeller we have the moving blade attached to this impeller. Each row of moving blade is followed by actually a row of fixed blade attached to the outer casing. So the fixed blade, those are the fixed blade attached to the outer casing, and those are the moving blades attached to the impeller in this case, and this impeller is actually rotating. Then we can have another row actually of moving blade, followed by another row of fixed blade, and so on. So the flow in this case is coming in the axial direction. The flow is forced to go actually in this smaller area or a smaller volume to be compressed between the fixed and the moving blade. Then the flow will be leaving axially. So in case of axial flow compressor, the flow is coming axial and also is leaving in the axial direction. In case of centrifugal flow compressor, the flow is coming axial, but the flow actually is leaving on the radial direction in this case. And in both cases, if you look at the flow passage here, if you look at the design actually of the moving blade, it takes actually the area, the diffuser shape. If you look at the area between any moving blade here and the outer casing, you can see this area, Shabab, is increasing also in the flow direction. When it comes here, the flow comes here. The area also between this impeller and this plate, fixed plate, should also take the area, the design of the diffuser. The area should always be increasing in the flow direction so that we can reduce the velocity, and in this case, the pressure will build up within the system. This design, either axial or centrifugal, we call it actually a dynamic flow compressor in this case. Dynamic flows, that means we are generating a tangential flow velocity, and this tangential flow velocity, we can force the flow to go actually a diffuser shape design, then we can generate, we can build the pressure within the system in this case. يعني this design يا شباب يعني can also draw, especially the axial flow compressor, it can draw more amount of air, and also it have few moving parts in this case, so it will require little maintenance in this case. But يعني this is also, we have the same actually drawback. It will result actually in limited increase of pressure and limited amount of air when the engine actually is running at lower RPM. And this is يعني شباب one of the drawback of the supercharger or turbocharger in general. At lower engine RPM, we cannot benefit actually from this turbocharger or supercharger. So the advantage of supercharger, it is quick solution for the boosting in power, because it takes the power. In case of supercharger, it takes the power from the crankshaft, so it does not depend on the exhaust gases, the amount of exhaust gases. Anyway, it can take the power, the input power to the compressor from the power output from the crankshaft. So usually, Shabab, if you have your car equipped with supercharger, usually when you try to press the accelerator pedal to increase the power, in this case, if you have supercharger, you will find the engine is just also responding to you a little bit faster than in case of turbocharger. Because in case of turbocharger, it just take the power of the exhaust gases, convert it into the turbine to the power of the compressor, then the compressor can compress the air. So this process takes a little bit longer time in case of turbocharger. But in case of supercharger, usually the compressor is running using part of the power of the crankshaft, so it responds actually faster in this case. So we don't have lag in response in case of supercharger compared to turbocharger, and also it can respond under lower RPM. Yani if you have your car is equipped with supercharger, you can have better response at lower RPM compared to the turbocharger. In case of turbocharger, as we said, it takes the power, the exhaust gases to drive the turbine. But at lower RPM or lower loading conditions, the amount of exhaust gases will be low, and it will be leaving at lower temperature. So the power input to the turbine will be low, and accordingly the power output actually of the compressor will be low at lower RPM in this case. But usually supercharger, because it takes the power, part of the engine power, then in this case it can result in faster response compared to the case of turbocharger. Also, its price also is cost effective, because in case of supercharger we don't have the turbine, just we have only the compressor, and the compressor takes the power from the crankshaft. But in case of turbocharger, we need to have a turbine, so this is additional part. So in this case, that will add actually to the cost of the engine. So the disadvantage, those are the advantage of the supercharging, but the disadvantage actually is less efficient, because here the supercharger, it takes part of the power of the engine, part of the crankshaft power to drive the compressor. Then in this case we have positive effect for the compressor to increase the amount of air, to increase the engine power, but actually on the other hand we just consume part of this engine power in order to drive the compressor. So it is less efficient compared to the turbocharger, and also it increases the strain rate of the engine and also the running gear, because in case of supercharger, as you can see here, we should have a connection gear. So this is a kind of addition that will actually raise the strain, and it will increase the moving part of the engine in this case, and it will require actually additional oil in this case for the lubrication. Also the reliability, shabab, as we are running the engine, and this is in general for super and for turbocharger. In general, we increase the engine, the intake air pressure, increase the amount of mass flow rate of air, then we can increase the amount of mass flow rate of oil. So the engine in this case will be running under high pressure and high temperature in this case. And this should little bit reduce the longevity of the engine, the working or the lifetime of the engine in this case. So if you are to buy a used car, this car actually is turbo or supercharged, you have to make sure actually that it is not actually very old, because usually the lifetime for a car, turbocharged or supercharged, will be less than the case actually of naturally aspirated car. Because turbo or supercharged, that means the engine actually is overloaded. It can actually provide more power under higher pressure and higher temperature, which can generate more stresses actually on the engine itself. So the engine life, in case of turbo or supercharged cars, this will be actually reduced, or it will be actually less than the lifetime for a naturally aspirated engine also. Also, shabab, with time, if we have a car, turbo or supercharged, if you have a used car or something, you are going to use a used car which have turbo or supercharger, then in this case you have to check actually the turbo or supercharger. Because if there is a problem in turbo or supercharger, you have to fix it, or you have to replace the turbo or supercharger in this case. Because the engine cannot run without the compressor. You cannot say, I will just remove the turbocharger and the engine will be running fine. No, this is not the case. The engine has been designed to have a turbo or supercharger. Then in this case, it have to have it. If you removed it, in this case, actually, it will result actually in a lot of problem, and the engine power in this case will be reduced very significantly in this case. Okay, so if you have a car, turbo or supercharged, it has to be working with the turbocharger. And if we have a problem with this turbocharger or supercharger, we have to fix it, or we have to replace the whole turbo or supercharger system. And this will result in additional cost. Okay. And as I said to you, the longevity or the lifetime of this engine should be lower than the case of naturally aspirated engine. Okay. This is regarding the supercharger, in which we have a compressor that takes the power from the crankshaft. And we said this is one of the drawbacks of the supercharger, that it takes part of the power output of the engine in this case, so it will be less efficient, as we said. But as we said, supercharger has one main advantage, because it takes the power from the engine, so it can drive a kind of better boosting condition at lower RPM, and compared to the turbocharger. Here is the turbocharger, as we said. Turbocharger in this case, shabab, as we said, when we open the exhaust valve during the exhaust stroke, so the exhaust gases will be leaving. And we have represented this part last time on the engine cycle, on the PV diagram. We have seen that there is a kind of energy which we call it the blowdown energy, because the gas is leaving under high pressure, and the exhaust gases just expand outside the engine in the atmosphere, and this is kind actually of lost energy. We can recover this amount of heat or energy in the exhaust gases through actually exhaust gas turbine. We can have a design to have a fixed blade. This is the fixed part, shabab, or the casing. We reduce the area here in order to increase the jet velocity of the exhaust gases. Then it can hit the blades of the turbine. Then it can run the shaft of this turbine. On the other hand, we can have a compressor on the same shaft that it can take the air, handle the air, and then it can compress the air in this case and compress it into the engine and raise its pressure, so it can increase the mass flow rate of air in this case. As we said, shabab, in all cases, super or turbocharger, the air leaving the compressor here should be passed through an intercooler system, a cooling system, like the radiator of the car. In this case, this cooling system could be done before using the cooling water circuit in the car, or usually in most of the cases we use the coming air, the forced coming air while running your car. In this case, the air will be coming at higher velocities, and we can pass it actually around. It's very similar to the radiator system in front of your car. Then it can reduce actually the temperature of the air. This is what we call the intercooler, reduce the temperature. That means it will improve the density of the air, and then we can increase the mass flow rate of air. Here you can look. This is where is the intercooler is located. This is the exhaust gases leaving the engine. It can run the turbine. Turbine is running the compressor. Compressor takes the air from the atmosphere, and then it can compress it. Then the compressed air is passed actually through the intercooler before it is being introduced to the intake manifold of the system. But in this case, this turbocharged system, the turbine and compressor have a separate shaft running at a separate RPM. This is actually wholly separated from the engine. So in this case, this shaft actually can spin at very high RPM. It can approach actually 100,000 RPM in this case. And the turbocharger in this case can be highly effective at higher RPM. When we have enough amount of exhaust gases, this can drive actually the turbine, and it can generate actually high power to the compressor to actually provide more air to the engine, and then it can increase the power of the engine in this case. If you look at where turbocharger or supercharger is located in your car, turbocharger mainly, usually the turbocharger is just attached very close to the engine. So here usually the air is coming, it passes through the air filter, and then this air actually is passed through the compressor. This compressor is driven by the turbine here. Then it can compress the air to the intake manifold, and then this air is introduced to the engine. The engine exhaust out of here is just introduced to the turbine, and then after the turbine we can just take the exhaust gases actually to the exhaust tailpipe at the exit actually to leave the car in this case. So usually if we have turbocharged engine, the turbo will be just attached very close to the engine in order to take the exhaust gases here at higher temperature. Then it can drive the turbine to drive the compressor. Okay, we have different design for turbocharger. We have either constant pressure turbocharger, or we have Balsa turbocharger, or we can have a combination between them, which is called the Balsa converter turbocharger. In case of constant pressure turbocharger, in this case, as you know, the combustion in internal combustion engine is intermittent combustion. So we have intake stroke, then we have compression, and then we have the power stroke, we have the combustion or the power stroke. Then we have the exhaust gases are leaving in the exhaust stroke. And we will be waiting actually 3 other strokes until we have another exhaust stream is leaving, another exhaust stroke. So the flow of the exhaust gases in internal combustion engine is intermittent flow. That means it is pulsating flow. So the pressure is changing. But if I need to drive this turbine at a fixed pressure, we need to fix the pressure output of the engine of the flow. So in this case, we have to use in this case a kind of common manifold, which is actually have a bigger volume. Then we can accumulate the exhaust gases in this common manifold out of all of the cylinder. Then in this case, we can pass the exhaust gases out of this common manifold. We can just pass it to the turbine in order to generate the power in this case. In this case, if the manifold pressure is high enough, then in this case, we can take benefit of the blow energy, which is the blow down energy out of the exhaust gases. Then we can convert it actually to work inside the turbine. And as this pressure increase inside the common manifold, then in this case, as the recovery ratio of the blow down energy can be increased, and the power of the turbine will be increased in this case. But usually here, if we are using a common manifold, all of the cylinder will be just exhausting the gases to this common manifold in order to dampen the pressure, to have fixed pressure to the inlet of the turbine. This means we are losing part of the energy, because once we open the exhaust valve, the pressure inside the cylinder is very high. If we took this pressure pulse and just pass it to the turbine, then in this case we can have higher power. Damping the pressure in this case in the common manifold will reduce the power output actually in this case. So if there is another solution, which is the pulsating turbocharger, in which instead of having common manifold for all of the cylinder, we can have actually separate exhaust pipe for each cylinder. And this separate exhaust pipe will be directly connected to the turbine. So once we open the exhaust valve, this high pressure pulse will be just transferred to the turbine in this case. And it will be running the turbine at higher RPM. And it will give actually the most of the blow down energy in this case. And each cylinder have a separate exhaust pipe. So at each stroke, for exhaust stroke for each cylinder, in this case we can utilize most of this energy to generate power in the turbine in this case. But usually يا شباب here the flow is pulsating, so usually the turbine is subjected to pressure pulses and it will be vibrating in this case. So this is one of the drawbacks over the pulsating turbocharger. So there is a third solution in which we don't use a common manifold, or we don't use also in this case, sorry, we don't actually in this case damp the pressure, reduce the pressure too much, so that we can use common big intake manifold or bigger common manifold in this case. And also we don't use the pulsating flow. We need to reduce the pulsation so that we can reduce the vibration of the turbine. So instead we can use a kind of Venturi junction. Venturi يا شباب, we just restrict the area and the flow direction of the exhaust gases. And also يا شباب, we use a common manifold, common exhaust gas manifold in this design for all of the cylinder before introducing the exhaust gas to the turbine. But in this case, we provide the design with a kind of a Venturi. So when the flow, actually the common flow, common exhaust flow is going through this Venturi, area velocity will be reduced in this case. The velocity will be increased in this case, and the pressure will be reduced. So the pulsating flow at higher pressure in this case, when we pass it through this Venturi, it will try to damp this pressure pulse. So instead of high peak pressure, so it can reduce actually to almost fixed pressure. But this fixed pressure will be still higher than the case of actually higher than the pressure loss actually when we have a common manifold. If we have one common manifold of a bigger volume, it will damp the pressure too much. So the pressure of the exhaust gases will be reduced too much in this case. But when we use a Venturi, this Venturi actually will just damp this pulse, but it will not reduce actually the pressure too much in this case, so that we can have more power to drive the turbine in this case. This is what we call actually the pulse converter turbocharger, which use a Venturi meter, common Venturi meter for the common exhaust gases in order to reduce actually the level of the pulse or the pressure pulse in this case, so that we can reduce the vibration in the turbine. طيب, in order to control the operation of this turbocharger, let's say the engine is running at higher RPM. So higher RPM, that means the amount of exhaust gases out of this engine will be too much in this case. When it goes to the turbine, then in this case the turbine will have higher power and it will transfer this power to the compressor. Then the compressor will transfer more amount of air actually to the engine. When the engine is introduced here actually with more amount of air, more amount of fuel will be burned, and in this case the power of the engine will be too much increased in this case. We call it in this case overboosting of the flow. So this may cause a shabab that the engine, this is piston which is just pulsating flow we have in this case it moving up and down, so at a given speed. It is designed actually to have a given speed, maximum speed. So when we increase the amount of mass flow rate of fuel beyond a given value, then in this case the power of the engine will be much increased and the speed of this piston will be highly increased. So in some cases actually it may cause a kind of tire traction. The engine can be just stopped. It will be just moving at one part in this case due to the high speed of the engine. It may cause tire traction, or the engine actually the engine can totally be destroyed in this case. So in this case, we need just to limit or control the operation of the turbocharger so that we can avoid actually the overboosting case. In this case, we can use what we call the waste gate. Waste gate يا شباب is just connected here to the exhaust manifold. It is operated by actually a pressure line coming from the intake manifold. So the intake manifold gives us a signal about the pressure of the air inside the intake manifold. This pressure signal, we can even take part of the flow. This is manual control design, in which we can take part of the flow here just to transfer the pressure pulse of the air inside the intake manifold. So here we have a valve. This valve will be subjected upward by the pressure of the air in the intake manifold, and downward actually we have the pressure of the exhaust gases. If we have at higher RPM, the mass flow rate of the exhaust gases is too high, so the mass flow rate of air will be too much, and the pressure of air in the intake manifold will be high in this case. If the pressure is high, it will just compress this spring here, يا شباب, upward. It will be moving it upward, so that it can take the intake valve upward, and the part of the exhaust gases can be leaving the engine in this case. So it does not go to the turbine in this case, in order to reduce the power of the turbine, and then we can reduce the pressure of the intake manifold. So the use of the wastegate is to keep the cylinder pressure inside the engine at a given safe limit to avoid excessive engine stresses and excessive engine power, and also it protects the turbocharger under very low or very high exhaust manifold pressure in this case, or exhaust manifold flow rate. So the main idea, شباب, of the wastegate is just we can bypass some of the exhaust gases under higher pressure of the intake manifold in order to just avoid actually overboosting of the engine power in this case. Okay, this is the wastegate. We have another control method actually for the turbocharger. Is that we can use actually a kind of relief valve. In case of part load, يا شباب, part load or at lower RPM, usually the throttle valve, which is connected to the accelerator pedal, is just opening very small opening in this case, or we can say it is closed, almost it is closed. So if we have a turbocharger, the compressor will be compressing the air. So this air has to pass through the throttle valve, and this throttle valve during the part load condition is almost closed. So this will result actually in high pressure rise in the intake manifold. So in this case, we can use a kind of, it's a kind of bobbed valve, we call it a relief valve. The idea, شباب, of the relief valve, we have a piston or a valve. This valve is fixed by a spring. So when the pressure below this valve is high enough to overcome this spring force, then it can raise the valve and the part of the air will be leaving the engine in this case. So we have two ways, يا شباب, to control the operation of the turbocharger. Wastegate, which is used actually operating using the pressure of the intake manifold, controlled by the pressure of the intake manifold. If it is high enough, then in this case it will pull up this valve, then we can have some exhaust gases leaving to the atmosphere without passing through the turbine, in order to reduce the power of the turbine and avoid actually overboosting of the engine power. Another way to control is the relief valve. During the part load condition, in which we have the throttle valve is almost closed. So in this case, we use a relief valve in order to just allow air to be escaped to the atmosphere in this case. So in case of supercharger or turbocharger failure, شباب, as I told you, in this case, there will be much drop in the engine power. It will be noticed in this case. And in this case, شباب, we have either to rebuild or repair, and in some severe cases, we have to replace this turbocharger. We cannot say that we can just take this turbocharger out and the engine will be running. No, the engine will not be running in this case, because there will be actually much drop in the engine power in this case, and we have to replace this turbocharger. As I told you, شباب, turbocharger or supercharger system, it increase more power. It can reduce the fuel consumption rate, but the engine longevity, the lifetime of the engine will be reduced. And also when we have a problem with the turbo or supercharger, it has to be fixed, because the engine cannot run without the turbo or the supercharger if it is designed for that. Okay? And also, شباب, at lower RPM, if you have a car and you are actually driving within the city, so you have lower RPM, usually the car is moving at lower speed in this case. So usually in this case, the effect of the turbo will be at the lower level. So as you can see here, يا شباب, we said all of the compressor, usually at lower RPM, will not be able actually to have enough power to raise the pressure of the air. So almost we don't have boost at lower RPM. So usually we can benefit from the turbo or supercharger at higher RPM. If you are driving on the highway or something, then in this case you will see the effect of the turbocharger. Otherwise, at lower RPM, most of turbo or supercharger design, you will not take any benefit from the turbo or the supercharger. Okay, شباب? Is that clear يا شباب? Is it clear? Bashari, is it clear?
واضح.
طيب.
Yes, دكتور.
طيب, this is a شباب, يعني let's see, as we said, it can improve the power. Also, it can improve, in this case, the fuel economy. It can fuel consumed per unit brake power output. This can be reduced also using a turbo or supercharger. Here يا شباب, we have يعني the performance of a diesel engine. Fueled by diesel fuel and biodiesel fuel. Biodiesel يا شباب, we said this is a kind of biodegradable source of fuel that we can get from the used oil or biodegradable oil. يعني, as we said in, I think, in the first chapter or in the second chapter, this have actually very the characteristics of the biofuel is very close to the diesel fuel. However, the chemical structure is not very close. It is totally different in this case. But usually it has, the biofuel يا شباب, has lower calorific value compared to the diesel fuel. But this biofuel يا شباب, when we burn it, if we have biodegradable source, when it results in carbon dioxide, this carbon dioxide can be absorbed by the plant in the photosynthesis process, and it does not cause actually what we call the global warming. So this is the main idea of the biofuel. It is biodegradable fuel. It does not result actually in carbon dioxide emissions that can cause actually what we call the global warming. It have يعني very close properties to the diesel fuel, but it has lower calorific value. So usually when we run a diesel engine using biofuel, so in this case the engine power will be reduced because the heating value of the fuel itself is lower than the case of the diesel fuel. But anyway, let's look here. If we have the diesel fuel, let's يعني forget about the biofuel. Consider a diesel fuel engine. Compare the naturally aspirated engine with turbocharged engine. So here, شباب, if you look at here, the top line is representing the turbocharged diesel engine, and the third line here is representing actually the naturally aspirated diesel engine. So as you compare, شباب, here, if you compare those two lines, you will find there is a big difference in the power output of the engine in this case between the naturally aspirated and the turbocharged engine for the same displacement volume, شباب. Yeah, let's say the car is running usually very close to 2000 RPM. If you look at 2000 RPM, the naturally aspirated engine will be giving a power of about 40 kilowatt, but for the turbocharged, it will be giving a power very close to 50 kilowatt. So 50 minus 40, it will be 10 over 40. That means we have about 25% of the power output. We do have about 25% increase in the power output in this case of the engine. So if we have a turbocharged engine running at 2000 RPM, then in this case the engine should have يعني increase in power output of about actually 25% increase. If you look at the brake specific fuel consumption, I'll be talking about all of this definition شباب inshallah next chapter. But look here at about the brake specific fuel consumption, which is the amount of fuel consumed per unit power output, per unit brake power on the crankshaft. Let's consider also the diesel fuel. The lower line here is representing the case of diesel fuel naturally aspirated. The diesel fuel turbocharged. And the third line is representing the basic diesel fuel naturally aspirated. So here يا شباب, this line, which is the second line from the top, this is the diesel fuel for naturally aspirated. This is the fuel consumption. المضاد fuel per unit power output. We call it the brake specific fuel consumption. The amount of fuel that we consume per unit power output. This is the line for naturally aspirated, and the brake specific fuel consumption, the lowest line will be the case actually of diesel engine under turbocharged condition. So if you look at 2000 RPM also, you will find here this is the value. It will be around 250 gram per kilowatt hour, and the case of diesel fuel, this is شباب the case of turbocharging about 250. The case of naturally aspirated will about يعني a kind of 300 in this case. So we have a kind of 50 difference. So 50 over 250, that will be a kind of about 20%. So that means, شباب, we have lower fuel consumption in case of turbocharged engine compared to the naturally aspirated engine. We can reduce the amount of fuel consumption by about 20%. So let's say if you are fueling your car each week. So after 5 weeks, using the naturally aspirated engine, you should have fueled 5 times. But actually, in case if you have a turbocharged car, in this case, you will be fueling only 4 times during those 5 weeks. So in this case, شباب, we have reduction in a specific fuel consumption. That means the engine is consuming less amount of fuel in case of turbocharging. And also it can produce, in this case, شباب, higher power. And also the torque will be increased. And also the thermal efficiency based on this increase in the power output and reduction in the amount of fuel, the thermal efficiency will be increased also, will be increased in this case. Type, those are the advantage of the turbocharged or supercharged engine. It can increase the horsepower. We have better fuel economy. The amount of fuel per unit power output has been reduced. And also the efficiency of, in case of turbochargers, the efficiency will be increased because the turbocharger, in comparison to the supercharger, it is running out of energy. Because in this case, just we make use of the energy in the exhaust gases, which we call it the blow-down energy. Just we take this energy and run a turbine, and the turbine run a compressor to compress the air. So we don't consume part of the energy output of the engine in this case. So this will result as a turbocharger is preferred compared to the supercharger, as in this case actually it will improve the efficiency of the engine in this case. But the main disadvantage that we have turbo lag, because as we said, the exhaust gases should go through the turbine, and then the turbine should run the compressor should compress the air, and then this air will be introduced to the engine. So it takes some time in response. So there is actually a lag. So if you have a car equipped with a turbocharger, when you just press the accelerator pedal, you will not have actually a fast response. You will not find the car is moving very fast immediately. No, it will take a little bit some time. So there is a delay in response if you have a turbocharger compared to the supercharger. In case of supercharger, supercharger, the compressor is driven by part of the power of the crankshaft, part of the engine power. So usually when you try to press the accelerator pedal, if you have supercharger, you will find in this case immediate response because the compressor is taking part of the engine power. But in case of turbo, if you have a turbine, then there will be actually a delay in this case. When you just press the accelerator pedal, it will take some time until you have actually a response in your car. Also, there is a post threshold in which actually we cannot get any benefit from the turbocharger, especially for the turbocharger. Supercharger, it can drive little bit improved boost at lower RPM. But in case of turbocharger at lower RPM, the amount of exhaust gases is very low. So it cannot drive actually enough, you cannot generate actually enough power in the turbine to drive the compressor at lower RPM. So usually at lower RPM, we don't have any benefit actually from the turbocharger. And also at higher RPM, there is a limit, which is called actually the power surge in this case. We cannot increase actually the power output of the turbine too much at higher RPM, so that in this case the amount of air will be too much and the fuel will be too much. So in this case the engine power in this case will be increased and it will be actually increased above the limit of the operation of the engine. It may cause, as we said, car traction, and in some severe cases it can destroy the whole engine. That's why we have to have the wastegate and the relief valve in order to control the operation of the turbocharger. So at lower RPM, we don't have fast response. We don't have response from the turbocharger. At higher RPM also, we should limit the operation of the turbocharger because in case of larger size of turbo, it may result actually in excessive engine power in this case. So we have to limit the operation at higher RPM as well. Also, Shabab, the turbocharger, it gets hot after the operation because it deals with the exhaust gases. So in this case, it will require actually additional supply of engine oil. Unlike the case of supercharger, with supercharger, we don't have turbine, just we have a compressor. So it does not, almost in case of supercharger, it does not require engine oil or engine lubrication in this case. But in case of turbo, as it is dealing with the exhaust gases, so it gets hot very soon, then it needs actually additional oil additional oil for the engine in this case. That's why in your car for the service, شباب, if you have a turbocharger, then in this case the amount of oil to the engine will be higher. We need more amount of oil to the engine in this case. Okay. طيب let's يعني continue إن شاء الله next time.